Okay, everybody. Let's see. All right, we got okay. So, picking right up from where we left off last. Let me open up all my files. So now, I'm at the point in this game. So I'm recreating the Suika game, which is a simple game where you drop fruit on top of each other, and if they're the same fruit and they touch, they combine to form a bigger fruit. And once you get to the watermelon, it disappears, and that clears up space for you to drop more fruit on top of each other. And if you fill up the box or the container that you're dropping fruit into, then it's game over. So currently, I'm able to render multiple objects. That was what we accomplished in the previous stream. I'm able to add new objects. For example, let's add one here. That is a grape. So yeah, I'm able to add one there, add new objects. The objects are able to rotate independently of each other, or well, just the objects are rotating instead of the camera rotating. So that's the extent of which I have this game working at this point. So for this stream, we're gonna start off by making the fruits different sizes. So I'll open up my JavaScript files, and then we'll dive right in. Different sizes. So I'm thinking just off the top of my head that we're gonna add a scale. And then I'm gonna have a map of all the various um, objects and their scale value. Uh, let's call it that. Fruit sizes. So very top, let's define fruit sizes. Grape. Let's see. Second biggest is cherry. Third biggest is lime, followed by lemon, followed by honeydew, followed by apricot, followed by um, pineapple. No, dragon fruit, followed by pineapple, followed by coconut, followed by watermelon. And the watermelon is 1.0. Let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think that covers all of them. Zero. And so all the fruits from the watermelon are gonna get smaller and smaller. So let's just try this. Hmm. Yeah. So 0.2 is going to be double the size of 0.1, which I think that's going to be a bit too too aggressive. Want the changes to be more gradual. So 1.2, 1.5 maybe, 0.15 maybe rather. Now this can be zero point 0.2, and then as they get bigger, then they get proportionally it increases a lot more. Zero point 0.2, zero point 0.3, point 0.5, 0.65, 0.891, 0.8910. Does this work? Let's see if any of them feel a bit too sudden. So this is an increase of 0.02, increase of 0.03, an increase of 0.05, an increase of 1. Maybe this is a bit 0.05, 0.07. How about that? And then 1. And then 5. 1.5 maybe? 6.5? How's that? And then 2. Yeah. 2. Nah, 2. Let's see. So this is increased by 1.5 there. How's that? It increases by 0.13, 0.15, 0.17, right? Yes, 0.17 and then 0.18. Let's try it out. Okay, fruit sizes. So yeah. Well, we can't try it out currently. So I've added scale to the object. So we have scale. Now let's see, what do we do with that scale? So it's part of the object. So I'm thinking in the draw scene, that's where I'm gonna um, utilize this factor. And I'm gonna put it in this one of these. Um, so we have this invert, transpose, translate. Yeah, translate. So these are just functions. Let's see. Alternatively, I could put it in the vertex shader. Um, as a as just a scalar value. Let's try that in float. Mhm. Scale. So I added it to the cubes vector shader. Now let me add it also to the circle vector shader, where it's much more important. I'm gonna follow the naming convention, even though I'm not really sure what the A stands, but I'm gonna follow it nonetheless. All right. So we got the scale. Might not work the way that I intended it. Yeah, I don't think it's gonna work this way. Revert. Pardon the baby crying in the background if you can hear that. Hmm. So I'm thinking I'm gonna have to put it here. Invert the offset, object.offset. Offset was a three-dimensional matrix, I believe. Yeah, so that translates. Let's see what other functions ML matrix or geomatrix matrix support or mat4s. Add, adjoin, clone, copy, create, determinant equals, exact equals, from quad, from scaling. So there is a scaling, YZ, frustum, get rotation, get scaling, invert, look at, multiply scalar. Okay, multiply scalar should work by a scalar. We could try this, multiply scalar. But first let me see if there is a scale function. Because there's a rotate, there's a perspective, there is a scale. In the given vex3, not using vectorization. So I suppose if you wanted to scale by different factors in the XYZ, that would be useful for calling this scale. But if I'm just multiplying everything, then maybe I should, yeah, let's try multiply scalar. So let's see. I wonder if I should add it onto this. The model rotation. Mat4 dot multiply scalar. Model rotation matrix. And then object dot scale. Mhm. So this was for the cube. Now let's also add it to the circle. Right here. Hmm. So I don't need to specify that it's circle rotation anymore. Model view. Hmm. Model view matrix. All right. Let's give it a go. Hmm. See if it works. No errors, so that's good. All right. Let's see. Um, great. 1, 1, 1, -7. So we have more space. Add fruit. All right. Cherry. Add fruit. Hmm. Kind of too. They're being obscured. Let's see. So 1, 1.5, 9. How's that? All right. And then cherry 4. Hmm. Lime 3. Lemon 2. Hmm. It doesn't look like they're being scaled much. Hmm. Multiply scalar. Object.scale. Object.scale. I am adding them in. Hmm. Well, all right. Um, so then let's try the multiply scalar. Multiply scalar. That's what I'm doing, right? Yes, that is what I'm doing. So that did not work the way I intended. Let's try doing it this way. Scale. So it's a vector. So I should do this, and xy should be the same because I want to keep it a circle. And the z is going to be 1 because that should stay the same. Whereas for a cube, should be scaled by the same amount, all 3 dimensions. All right. Hmm. X 2. Let's see. -10. Let's make it far away. Maybe too far. 9. But so actually, yeah, it's scaling. Yeah, that's great. Actually, I thought it was just too far. Let's see. 2, 1.8, 1.6. Yep. Cool. I think it's working. 1.2. Ah, lime. That's what I wanted. Yep. 1.2, 0.8. Want a lemon. Cool. Cool. Mm, lemon. Honeydew. 0.4. Mm-hmm. 0. Let's apricot. Okay. Cool, cool. Dragon fruit. -0.4. Yeah. Steadily getting bigger. Pineapple. 0.8. Okay. Coconut. 1.2. And then finally watermelon. Cool. Nicely scaled. It's further away than this watermelon, which is why that watermelon looks smaller. But cool. It's good. It's great. All right. So I got the scaling working. Make fruits of different sizes. Next up, transparent where no texture. Let me commit this first. Uh, see. Rice string. All right. Next up on the to-do list, transparent where no texture. So this is where for the pineapple specific. Um let's add one. Yeah. So you see in the drawing the center is supposed to be transparent or empty, but as you can see it's white. So I'm gonna have to fix that, and probably by looking at the code to see if it's doing anything by default for the color. Um, might be it might be the texture when it loads the texture. I want to check to see if it's doing RGBA or if it's just RGB. Load texture, RGBA. Okay. Pixel. All right. So blue by default. Um. Hmm. So from the code, it's supposed to take the um RGBA exactly, but it's not. Let's check the shaders. Circle, vertex shader. Um, yeah, vertex chord, uniform sampler 2D. Um, all right, I think it's time to Google it. Google. Okay, so frag color, frag color. It's doing this. I wonder what texture is. Hmm. Okay, maybe this is it. gl.enable, gl.blend. Let's try it in the draw scene. Load texture. Hmm. Try now. Ah, forget it. Pineapple. No, it's not working. Geo.blend. Sampler 2D, texture 2D, use sampler. Yeah, texture 2D. Using the above shader. Dot parts of my sprite to be transparent exactly. Geo dot. Try this. Hmm. No errors. Oh, it's behind. There we go. Hey, it works. Pretty neat. Yeah, surprisingly, yeah, not as not as big of an issue as I thought it would be. Cool. Thank you, Google, and thank you, X-Men 84. Let's see. Awesome. Well, strike this one off the list. Cool. So to dos left over are all JavaScript related. Gravity, object interactions with each other, and object interactions by the user. I think I'm gonna end the stream right here. Tend to my crying baby, see what he's up to. But yeah, thanks for tuning in. Anyone, everyone, all of one person. Thank you. Um, all right. See y'all next time.